Also, as a quick reminder, for more Microsoft webcasts, you can visit microsoft.com/webcasts. And again, I'd like to welcome everyone to today's MSDN webcast, Windows Communication Foundation, top to bottom. Today's session is part 7 of 15, Messaging Patterns. And now, without any further delay, I'm going to turn the floor over to today's presenter, Michelle LaRue Bustamante.
Thank you, Tracy. Hi, everyone. Welcome. Today we're going to be talking about messaging patterns with WCF, and like Tracy said, this is part 7 of 15. My name is Michelle LaRue Bustamante, and I'm an architect with iDesign and a Microsoft Regional Director. I do a bunch of other things as well, but the main purpose of this slide is to point out a couple things you care about, and that is that for today's webcast, the code that I'll be demonstrating is all available on my weblog at the bottom of this slide here, thatindigogirl.com, and that's where I posted all of the code for my book, Learning WCF. And if you are looking for other tips and things related to conferences I speak at and so forth, you can go to dasblond.net. So That Indigo Girl is dedicated to the book, and like I said, that's where I'm getting the code for my demonstrations today. So what we'll be talking about today is messaging patterns, and essentially the purpose is to get you up to speed on some of the different types of patterns, including some of the binding settings that might be related to messaging patterns. So I'll be talking about typical message exchange patterns like request reply, one-way, and duplex. And then I'm going to get into, briefly at the end of the webcast, some patterns like publish and subscribe and how you might implement that with duplex. And then also how we deal with things like large messages using streaming and MTOM. What you need to be prepared for before this webcast is essentially your basics with building applications with Microsoft.NET, of course. And then given that we've gone through 6 other webcasts in the series, you want to be aware of how to build a WCF service and client, and how to work with data contracts and service contracts, at least on some level. So I would recommend that you review webcast 1 and 2 at a minimum in this series if you haven't already. And in the meantime, of course, stay tuned and see what you get out of today. So like I said, the agenda will be, first I'll talk about the classic message exchange patterns and how we achieve those using WCF contracts and so forth. And then we'll get into a couple of other details that you need to know about, like publish, subscribe, and message transfers that are larger than normal using MTOM or streaming, and sort of what the benefits are of using either approach. So let's just start with where we are today. In terms of the webcast series so far, I've really been talking about things like service contracts, bindings, hosting, and in the process we haven't really got into anything other than request and reply operations, which is the default behavior when you create a service contract. So your operation signatures by default will be request and reply. And what that means is that when we produce the web service description language contract, the WSDL shows both an input message and an output message for each operation you might call at the service, which implies that clients always receive a response. And so like typical HTTP communication, a message comes in, a message comes out. And the message that's returned is inside a body element, inside the SOAP envelope. And that, of course, could be either a message that comes back or an empty return if the signature of the operation is void, a return, or it could be a fault if an exception is thrown. But the point is that there's always a message going back to the client, even if the client doesn't care about the response. When we talk about one-way operations, one-way operations are created by labeling it with the operation contract attribute. So this is the same attribute we apply to our operations by default in a service contract. But by setting it to one-way, the WSDL will show only an input message. And with an input message, again, what that implies is that an exception, if thrown at the service, will not be reported to the client. And I'm going to talk a little bit about that as I go through a demonstration. When you want to label an operation as one-way, what we do is we set the isOneWay property of the operation contract attribute to true. And that requires us to have a void return on the signature. Or if you're doing VB, that means it would be a subroutine instead of a function. So the point is that this is all you need to do to label an operation one way. And what that will achieve is that, again, there is no response sent to clients, which also implies that when the channel receives the message at the server, the client, basically the connection with the client is released, and then the server simply processes the message. If an exception is thrown, it's thrown up to the channel at the server side, but never reported back to the client. So let's actually go through a quick demonstration of the significance of this, and then we'll take it from there. So I'm going to share my desktop. And I'll go through a quick example that just illustrates. So let's just wait for this to refresh here so that you can see my desktop. So what you should be looking at now is I have a simple solution here with a service contract with a Hello Indigo message that returns void, but currently it's not a one-way operation. So the operation contract is currently just using the defaults. And in terms of what the operation is going to do, it's actually going to throw a not implemented exception. Now because this is not one way, we will expect to receive a response at the client. So what I'm going to do is quickly show you what happens when we try to invoke that service. So first I'll run the host, and I'm going to run it without debugging so we don't get all of the extra breakpoints, if you will, when the exception is thrown. So the host will just be waiting for clients to now call in to that operation. And let's take a quick look at the client code. So the client is actually going to do the following. It's going to create an instance of the proxy. It's going to make a call to Hello Indigo and then write the results to the console. If an exception is caught, it will write the exception to the console. And then it's going to try and use the proxy again and do the same thing. So let's run the client. So what you see here in the output window is that first I got an operation not implemented exception, and we reported that to the console. And then I got another exception saying the communication object cannot be used. Now if you recall from the exceptions and faults webcasts that I did several webcasts ago, we talked about the fact that if you have any type of session, then what will happen is the server channel gets faulted, thus the client channel is also faulted, therefore the proxy is no longer useful to you. And that's because we have a transport session, which is TCP binding being used right now. And the same thing would happen if I was using HTTP with reliable sessions or with secure sessions. So let's go ahead and shut down the client for a moment and then make a change so that it's going to be one way. So I'm going to shut the service down. And let's start by editing the operation contract. So what I'll do is I'll set one of the properties of operation contract attribute to is one way equals true. And now my service, of course, because this is a void return, will respect that this is a one-way operation and no longer report exceptions. Now, the other thing we have to do is update the client proxy to reflect the same. In fact, you'll get some strange results if you don't update your proxy to say that it's a one-way operation. It'll just hang. So let's go to my proxy, which was generated by Service Utility. And in here, the operation contract attribute, I'm going to set is one way equals to true again. And so now we are equivalent on the client and on the service. So let's go ahead and run the host once again. So I'll start the host, again without debugging so that we don't hit breakpoints at the server. And then while that's getting going, let's run to the client. And I'll throw a breakpoint in the client. So the client will first stop at creating the proxy, so we'll hit a breakpoint here. Oops. One second here. I forgot to remove something, which actually is something I should explain to you as well. Let's go back to what I edited. Since I did this by hand and didn't use a refresh of the service of the client proxy, what you'll see here is that since I made one way equal to true, what you'll notice is that there's an action and a reply action. These are web service terminology that I've mentioned in earlier webcasts that basically refers to when the message comes back, what does the action say, the addressing header. And since we are doing one way, we should no longer have a reply action. So I'm going to just remove that. What happens when you generate a proxy, as opposed to the service, which didn't explicitly say what is the action reply action, it's inferred from the service contract namespace. And so just as a refresher, this namespace plus the contract name plus the operation name, which would be Hello Indigo, is automatically sort of compounded to build this action and reply action. But when you generate a proxy at the client, it explicitly puts all those in there, so I forgot to remove that. So let's go ahead and run it again. And so we'll create the proxy, and we'll call Hello Indigo the first time. And notice that there's no exception. It seems to have worked. So we're going to write to the console that we completed the first call. And now let's try to use the proxy again. And this time we got an exception. So let's continue, and we'll see what the output is. The socket was aborted. Oh, well, that's because we timed out. Let's run it again real quick, and you'll see a different result, okay? So I'll run it without stopping on the breakpoints. And once again. So essentially, this time I just ran through, and I called two one-way operations. And you'll notice that we didn't see any results in terms of the proxy not being useful any longer. That's because we don't get a fault returned from the service when we call one-way operations. So at this point in time, the client proxy doesn't know that the server channel has actually faulted. But in fact, the server channel is indeed faulted, and it's not executing our operations at all. So if I were to call another operation subsequently that is not one-way, at that point the client channel would fault. And that's because we have a session. Like I said, all of this is related to sessions, and it's something that I discussed in my exceptions and faults webcast. So the point what we want to make here is that with one-way operations, we do not report exceptions, but that doesn't mean that an exception does not tear down the server channel. If you have any type of session, TCP, named pipes, HTTP with reliable sessions or secure sessions, or if you have an application session, which I'll talk about in the next webcast, then all of those things will indeed result in tearing down the server channel and making the client channel invalid. But we will only find out about it at the client if the one-way operation, if a non-one-way operation is called. So just be aware of that, and I'll talk a little bit more about that in the sessions webcast coming next in terms of how to handle it. So one-way operations, the client shouldn't care about a response. However, what we do want is to at least know that the arrival of the message took place. And so that's where it could be useful to turn on things like reliable messaging, because that will give you some level of guarantee that the message actually was delivered to the server channel, and if not, report to you at the client that the message could not be received. And then another way to get reliability, of course, is MSMQ, something I'll talk about in another webcast as well. So that would be a way to get durable reliability as opposed to transient. Durable meaning that it's persisted to the machine somewhere. Even if the machine goes down, we don't forget the message. Now, if the server channel is faulted, like I said, the client is completely unaware until the next call, and that next call has to be a non-one-way operation, something that reports a response that says there is a problem at the server. So otherwise we won't know. Now in terms of scenarios then, where would I want to use one-way? Because obviously there are risks involved in terms of delivery. We want to make sure that it's a fire and forget type of operation where the client should not care. Did it execute or did it not? So something like a logging activity that's nice to have, or maybe publishing events in a publish-subscribe scenario. Another thing that you might see in terms of scenarios is that you have one-way operations, but then you have a way to poll for results. So in your service contract, you might have a polling operation that says, what is the status of my upload, for example, if you were uploading a file. And then that way the client can actually discover in some other way what is the result of what I did. Another thing you can do is have callbacks, though, and that would be using a duplex binding, where we can actually get a callback that says what is the result of the upload or whatever the one-way call was. And so with that, let's actually talk about duplex. And I'll just check the questions real quick and see if there's anything, but I don't see any questions yet, so I'll continue. Okay, so duplex operations then. What this allows you to do is, again, have a request come into the service and a callback report back to the client the results, let's say. Or let's put this another way. When the client makes a request to the service, it tells the service about an endpoint at the client side, which allows the service to, at any point in time, potentially send a message back to the client unsolicited. So the way we create callbacks is we establish a callback contract, which is again similar to a service contract, and we tell the service contract about the callback contract. I'll show you how to do that in a few moments. The point is that a callback contract is a separate contract with a set of operations in it, which are things the service might, messages the service might send to the client. And what will happen is the WSDL will show output messages for callback contract operations. And so it has to be deployed on a binding that supports duplex communication. Let's take a look at that. So the way we start is we define a callback interface, which is like a service contract. And it has operations in it, so we must use the operation contract attribute. They don't have to be one-way operations, but it's helpful if they are, because let's face it, does the service really care what if the client throws an exception when it receives a callback? Probably not. Does the service care if there's an exception when it publishes events and the client does not respond properly to those events? Probably not. So making them one way just makes it possible for the service not to care about any exceptions. Okay? Now, what happens when we create a callback contract is, again, we're establishing a list of one or more possible operations that the service might send or use to communicate with the client. But notice that there is no service contract attribute on this interface. We don't require a service contract because it's not a service contract, it's a callback contract. And so what will happen is the actual service contract that is respecting the callback contract will set up the callback contract in this way. The service contract attribute receives a callback contract property of type iHelloIndigo service callback. So the name of the callback contract is placed here. And what happens in terms of namespaces is the callback contract will always inherit, in terms of messaging, the namespace of the service contract. So even if, in the previous slide, I were to supply a service contract attribute here, it would be allowed, but it would not be looked at unless we applied this interface to an actual service. Okay? So in other words, the namespace would have been ignored here anyway, because we're going to always use the service contract namespace. What does that relate to? That's related to when a message is sent on the wire, inside the SOAP envelope, there's always a namespace, and that is how we disambiguate messages from your services from some other service that uses a different domain or namespace, right? So we associate the callback contract with the service contract, and then any operations that will potentially want to communicate with the client to let them know, yes, we finished with the operation. It's probably a good idea to make those one way as well. So in other words, if HelloIndigo is going to process some lengthy amount of work and then notify the client, why should the client wait for a response? There is no response. It's a void. So what we'll do is make it one way so that the client can be released of that communication and then just wait for a callback. Now, we're also going to talk about reentrancy briefly, and that's something that I'll go into in greater detail in concurrency webcast that's going to be coming up. But the point is that we should at least make it either one way, or we should enable reentrancy. So I'm going to take you through a demo actually and just go through the process of creating a callback contract and basically associating that with a service contract and consuming that from the client. So I'll go ahead and move to a different example here. So here is a starting point. What I have here is a service contract and a callback contract. So you can see my callback contract is iHelloIndigo. It's got an operation called Hello Indigo Callback, which is going to send a string to the client. Notice it's not one way at this time. Okay? And so how we associate that callback contract with the service contract is we say this is a callback contract. And we associate that with the service contract so that now every time an operation is called from the client, the service is going to be able to access the client's endpoint and communicate with it. So let's see how that works. Well, first of all, what I'm going to do is just host the service and write some code at the client, generate a proxy, and so forth. So let's go ahead and look at the host. So here I've got an app config which exposes that service contract on a dual HTTP binding. So what I mentioned before is that it has to be a binding that supports two-way communication because the client is going to supply an endpoint to be reached at. And so over HTTP, typically we don't have that, but if we use WS dual HTTP binding, we do have that ability because what happens is WCF creates two one-way channels that are WS HTTP binding equivalent. And I've got metadata exchange enabled so that I can generate a client contract. So I'll go ahead and run the host. And then at the client, what I'll do is I'll generate a proxy. So the usual stuff. So let's go ahead and add a service reference. Oh, I didn't shut down that other service, so I have to restart. I was already using the same port, so I'll restart my host again. And now I'll add a service reference. Go to my metadata exchange endpoint, and away we go. So this will generate a copy of the service contract and a copy of the callback contract for the client to use to initialize a proxy. But the difference is going to be that the proxy is going to need to know what is the object that should be instantiated to receive, what is the object that will receive callbacks when the service wants to communicate with the client. So just like at the service, where we supply a service type in the host, and we say, look, anytime a message comes in for Hello Indigo endpoint, this is the service object we want you to construct and pass messages to. Likewise, the client must construct an object that implements the callback contract. So what we'll see here is that I have a callback contract defined, and it's got Hello Indigo Callback as the message. What you'll also see here is that my proxy actually implements, instead of client base, duplex client base, which is a special base class that supports a duplex channel, which means that we need to provide to the constructor of the proxy the object that will receive the messages from the service. Makes sense, right? So what we're going to do is go to the form. And in the form, what I'm going to do is I'm going to implement right there. Oops, sorry, I have to stop debugging first. What I'm going to do is implement the callback contract right here on the form. So I'm going to just assume that we're receiving messages back there to the form. So I'm going to implement localhost iHelloIndigo service callback right here. And to implement that interface, we'll go ahead and implement it. And that'll give me a Hello Indigo callback. And instead of throwing an exception, what I'll do is I will show a message. And the message will be string format, message received on thread, and we'll display the thread as well as the message. So thread, current thread, and get hash code, and then we'll also display the message. Okay? So when the service calls back to the client, it's going to send messages to the form. So as long as my form instance is kept alive, everybody's going to be happy. And I'm going to show a message when that message comes back. So we'll throw a breakpoint in there. Now let's take a look at the code to call the service. So as you might expect, when I want to call the service, I need to create an instance of a proxy. And so we'll go ahead and create a localhost proxy. Now what you'll notice here, actually I'll just make an instance of the proxy and then we'll initialize it here. So in my actual form load, I'm going to, or in the form constructor, I'm going to implement or construct the proxy. And you'll notice that I'm supposed to provide this parameter called an instance context with the callback object, or callback context, if you will. Okay? And what that is, that instance context, is basically a wrapper for the object that implements the correct callback contract, which is what? This, my form, right? So I have to create an instance context wrapper for the object that will receive the messages, and then I have to provide that to the proxy when I construct it. And then from there, I can say m_proxy dot hello indigo, pass a message, hello from duplex client. And this is just what you would normally expect. So the only change here really is how we construct the proxy and the fact that we implemented the callback contract on the form. So we'll compile the client, and now we've got to go to the server and see how do we find out about the client endpoint, because basically what's happening is this instance context is providing information to the proxy so that when a message is sent to the service, information about where the endpoint is at the client to receive a message on the client channel, where it is. So let's go to the service. And what we'll do is implement the code inside Hello Indigo. And what we'll do is go to the operation context, current, get callback channel. So what happens is every single operation to this service contract, iHello Indigo service, is going to provide a callback channel of type iHello Indigo service callback. So what we want to do is store a reference to that and then use it to call back to the client. So iHello Indigo service callback. And callback channel, Hello Indigo callback. Sound familiar? So we're just going to echo the message back to the client. So I can retrieve the callback channel this way. I can use it to then communicate with the client endpoint. So just like the service has an endpoint that can receive messages, the client now has an endpoint that can receive messages, and this is how we access it. So let's go ahead and compile that. And we'll go ahead and run the host and the client again. Now we're going to see a couple things happen here. So the client will make an attempt. So we've got a proxy at the client. It's going to make an attempt to call the service. And what you're going to see is that the service cannot call back to the client because it's not one-way operations, first of all. And one of the problems that that causes is that if the service were to try to call into the client right now, the client is busy. Why? Because the client is waiting for a response. So the operation would deadlock. It's guaranteed to deadlock because by default, every service only allows a single thread to access it at a given time. So if we leave the service and don't release the lock, the concurrency lock, then we will never be able to return from the client unless the callback is one way. Now, a workaround for that is to make the concurrency mode reentrant, which basically only allows for callbacks, but does not introduce any other concurrency issues. And if I make this reentrant, then that will remove that error that we just saw. So let's go ahead and run it again. Now we're going to get a different problem here. I am going to lock up, and that's for a different reason, also related to concurrency and synchronization. So let me show you what that problem is, although I'm not going to go into detail about it because we'll be talking about concurrency in 2 webcasts from now. But let me just unlock the problem by showing you this. Right now, I'm in a form. The main UI thread is the thread that is going to be receiving messages from the service. And that's because by default, the callback object will join the UI thread unless we set use synchronization to false. So like I said, I don't want to go into detail about concurrency issues in this particular webcast because we'll be talking about that in 2 webcasts, but I do want to mention that, of course, because this is a UI thread, we're not going to be able to receive messages from the service when the client is busy calling the service. Make sense? So let's go ahead and run that again. So we try to call the client or service again, and we got our callback. So we hit that breakpoint in the client. Okay. So I think I'm just waiting for the message box to pop up. It's temporarily slowed down here. Okay. So let's go ahead and reverse this so that instead of being reentrant, what we'll do is make both the operation contract is one way, and we'll also apply that to the callback contract. So what I'm doing here is I'm saying that the call into the service is one way, which means that the connection will be released with the client before the service completes the operation. And then while the service is completing the operation, it's going to try and call into the client. But since that's a one-way operation as well, there's no issue with deadlock. So the concurrency mode no longer becomes an issue in that case. And of course, I need to update the client with this as well, right? So we're going to need to go and edit our proxy. So let's go ahead and go to Indigo Service, remove the reply action, and set is one way to true. Let's go to our callback contract, do the same, remove the reply action, and set is one way to true. And we'll run it again. Let the service host continue. And we get our callback. So no concurrency issues with the client. It basically is able to get back into the client without worrying about a deadlock, so we didn't get that message that we got before. Okay, so you might wonder, how can I apply this? And one of the things that you can consider is that services can retain a list of callbacks of all clients that have basically initiated communication with the service in, let's say, a publish and subscribe scenario, where clients pass their endpoints, if you will, to the service. The service holds on to a list of those endpoints, and clients that are subscribed will receive events from the service. Now, those events don't always have to be the result of a client calling a method in the service or an operation. It could be out of band. It could be triggered by a UI or some other event. And so what that should tell you is, yes, the service can retain a list of the callback contracts, provide a subscribe method, so something like this, where we have a publisher service that has a subscribe and unsubscribe, and then some other trigger might invoke events of the callback to any listening clients. And in this case, the publisher events interface describes a one-way notification. Now, of course, the client will only be able to receive those notifications if the proxy remains live, which means the channel remains alive. So that's an important point. This could be transient. The client could shut down and forget to call unsubscribe. So services have to be prepared to handle that event. Now, in this case, what I'm going to do is show you, I have a breakpoint set here in subscribe, and show you that I'm going to retain a list of all the subscribers. So let's run this solution here. And I'll load up 2 subscribers just for illustration. So here's my service. And right now nobody is subscribed. I'm going to load up another subscriber. So now I have 2 subscribers. I'm going to call subscribe at the service. And what that's going to do is basically add this particular callback to a list of callbacks retained by the form. So I'm adding to a subscriber list. You can see that, right? So the first subscriber has done it, and now the second subscriber will do the same. And we will I think it's, there we go. Okay, so I'm going to say notify, and what we got here is that we've got notifications that have been sent to both clients. If I unsubscribe from thread 1 and remove from the list, then only one will receive. So only thread 10 received a notification. You get the idea? If I subscribe again, then now I receive on both. Now, again, all I've done is I've retained a list of callback contracts at the service. So if I remove one of these guys without unsubscribing properly, the service thinks he's got 2, and an exception will ultimately occur unless I swallow that exception, right? So, of course, if the callback is invalid or the channel is invalid, we're going to get that error. So we would want to wrap those messages. The point is that you can leverage duplex communication to create a publish-subscribe scenario, although it is transient, and you do have to remember that clients can go away and forget to unsubscribe and so forth. If you want a durable type of experience, then you would do that using MSMQ on both ends. So let's just complete the discussion about duplex and publish subscribe, and then we'll move on. So duplex bindings, the callback contracts can only be exposed over bindings that can support two-way communication. That means TCP and named pipes. That means HTTP with only dual HTTP binding. And what that does is it actually creates two channels in order to create the illusion of two-way communication. So there's actually a one-way channel, WS-HTTP, coming in from the client to the service, and vice versa. The interesting thing about WS dual HTTP binding is that that also allows you to decide what port to receive the message out at the client. So we'll talk about that in a minute too. Now in terms of the proxy generation, you saw that we inherited duplex client-based T instead of client-based T, and that we were absolutely required to inform the proxy of the client-side object that implements the callback contract, right? We have to create an instance of that object, and it has to be alive and waiting for notifications. And we do that by providing the callback instance to the proxy. So we can implement the callback contract on any type. It doesn't have to be a form. In this case, I'm showing a new class that we create an instance of that implements the callback contract. And then we construct that object, pass it to the instance context, and initialize the proxy with that context. Same idea, right? The TCP or named pipes have a back channel to receive the callback, whereas dual HTTP binding has to provide an actual explicit endpoint with a port. You can actually customize what that port is by setting the client base address property. You can do this in code using the client base address property of the proxy, or you can use a hard-coded configuration that is editable in the app config file. More than likely what you're going to want to do, and we have a utility on the iDesign site for this, is dynamically maybe look for a port within a range at the client, and so that can be done programmatically. So as for issuing callbacks, the operation context has access to the current context, which has access to the callback channel that was passed in from the client. We use that to get access to the callback channel, and we use that to call any of the operations exposed by that channel. So it's really like calling a service at the client. And if you want to do publish subscribe, then you can use duplex to facilitate a transient result, and you can add reliable sessions, which I'll talk about in a later webcast, to improve the reliability of delivery, especially for one-way operations. MSMQ would give durability. Okay, so let's move on to a couple of other smaller topics. So this kind of concludes the discussion of message exchange patterns, which is request to reply, one-way, and two-way or duplex with callbacks. Now let's talk about some other messaging patterns that you might care about, or messaging aspects, like dealing with large messages. So one of the things that we didn't really have time to talk about in the bindings webcast is, how we deal with message quotas and things like that. When we have large messages, what will happen is the first thing that will go wrong is you're not going to have a large enough message size, received message size setting to support that at the binding, because the default is 65 or 64K. So if you have any sort of large message resulting from transferring large images, other media, file uploads and downloads, just very, very large reports, so large blocks of XML, query results, anything like that can obviously quickly exceed the 64K limit of a message. And we do need to know how to configure the binding and increase the message size for sure. And we can address the size issue in terms of performance. So there's also performance issues that follow when you deal with large message exchange. And there's a couple ways to deal with different aspects of the problem based on memory and size of transfer and parsing overhead, and that is using either MTOM, which is a XML protocol that allows us to transfer binary data in a more efficient way, or streaming, which allows us to reduce the overhead on memory. And then I guess a kind of hybrid result would be to chunk messages into small pieces to fix the memory issue while also getting the reliability of MTOM. So let's continue and talk first about MTOM. So this is an interoperable standard, and the first thing that it does is it reduces the overhead of the binary transfer. What does that mean? Well, when we transfer information to an operation, call an operation, and pass whatever the data is it expects, any byte arrays are actually base 64 encoded, which increases the size by 33% roughly. And so not only do we have overhead in generating the base 64 encoding and decoding it at the server, which is a parsing issue in terms of overhead, we also have the size issue. So the message is now bigger. So MTOM reduces both of those problems by doing the following. Okay? It basically treats binary data as an attachment, just like you're used to with multipurpose internet mail extensions when we do attachments in email. So it means that the message is no longer just an HTTP message with SOAP envelope attached. In fact, it would be an HTTP message with a SOAP envelope followed by other parts. And those other parts can be binary without encoding. Now, you can enable MTOM very easily. So all this might sound complex, but the truth is all you have to do is enable MTOM. And then, of course, increase your message quotas according to the size you want to allow for that particular binding. So if I want to allow, 5 meg, then I limit it to 5 meg. And that means I have to increase not only the message received size, but also the maximum size of array length. Why? Because the reader quotas include a string length limit and also an array length, and of course a byte array is treated as an array. So we need to increase both of those in order to allow for, say, a large binary attachment to be uploaded. Now, the best way to explain MTOM, other than what I've just said, is really to show you. So let me go ahead and illustrate with an example what happens when we work with MTOM. And so here's an example right now that has file upload service. And for simplicity, I just have a single operation that's one way that receives a byte array. I'm not actually going to save the file in this example, but I do have samples from my book that do save files and such. For simplicity, I just want to show that we got the message, because what we really care about is, did we get here, and what did it look like on the wire? As for the host, the configuration right now is going to be WS HTTP binding. Right now it's text encoding, but I am increasing the size allowed for the transfer. So the message array length, or max array length, the received message size, and then I'll actually talk about some of these other things after. So let's go to the client. Client is also going to be having the message encoding of text for now. Let's see what the client does. Client is going to send binary data, and what I'm going to do actually first, just to illustrate something simple, is I'm going to go ahead and create data and generate a byte array length of 200 to start with, just to illustrate a point. So instead of actually sending an image, because sometimes TCP trace doesn't like large files, really large files, in terms of showing you what's on the wire, so I'm just going to send a 200 byte array. Okay? And what I'm doing is I'm reading part of the image, 200 bytes of it. And then I'm going to call upload file and send that data. So let me go ahead and run it. And I'm also going to open a TCP trace session here. If you're wondering how to set up TCP trace with WCF and all the details related to that, we won't have time to go into it here, but I do discuss that in the book, and it is set up in the samples that you can look at. And the samples are all available still at indigogirl.com. Okay, so what I'm going to do is I've got a TCP trace session. I'm going to hit Enter, send some binary data, 200 of it. And you'll see that the message that was sent looks like the following, right? It's just SOAP XML content. The SOAP envelope is included right here. And this is base64 encoded data, okay? Now, we didn't send a lot of data here, right? So you're not getting the full thrust of the size of encoding and so forth. But let's go ahead and let's change this to MTOM and see what that does to the transfer. So there's two things I want to show you related to MTOM. First is when we send a small amount of data, what happens, and then what happens when we send a larger amount of data. So in the message encoding, I'm going to say MTOM is my encoding type now, and I'm going to edit the client to do the same. So this is an interoperable protocol. You turn on MTOM, and any platform that understands MTOM, most of the Java platforms already implement this, will be able to communicate with you because this is a standard. So what we're about to see on the wire is standards-based. So the client will once again try to send 200 bytes of data of the image that I loaded. So it's sending it now. Get rid of my breakpoints here. And on the server, or on the wire, what we see now is that it's multi-part related data, which means the first part is going to be the SOAP envelope separated with a MIME encoded boundary. So here's my SOAP envelope. And notice that the data is still here. Okay? Now, the data has been encoded still, so you're probably wondering, I thought MTOM doesn't do that. And you're right, it doesn't, as long as the overhead of building the separate multi-part related sections of the message is worth the size of the data being encoded, and 200 just doesn't warrant that. So let's bump this up to 1,000, and we'll run it again. And now what's going to happen is because the size of the data transfer is larger, and I think around 200 bytes is close to the number that is that threshold. Now, after the data has been sent, what we'll see is we will get multi-part related data. You see that? We have a first section with a MIME encoded boundary, which is the SOAP envelope. And in the SOAP envelope, you'll see this XOP include statement, which basically is a way to say, look, this is the MIME part that goes in this parameter, and it will not be encoded any longer. It will be pure octet stream. So the MIME boundary is here separating the parts. Here's the second part. It's binary, and there it is. You see it looks different, yeah? Okay. So that's MTOM, and now, again, what does that do? It means that this second part does not need to be decoded because it's binary. It means that the XML parser doesn't have to work so hard to reconstitute the actual message at the server, or vice versa. And it means that we've reduced the size overall of transfer because as, of course, the binary data gets larger, the encoding would blow significantly. What it doesn't do is help us handle the problem of memory usage, and that's where streaming comes in. So the last thing I want to talk about is streaming. So MTOM helps with parsing and size of transfer, but you're still going to load that entire image or binary data into memory at the client in order to send the message and at the server in order to receive the message. When we use streaming, what happens is the service model, WCF, reduces the memory usage by directly pulling and sending from a stream of your choice. And so although we will lose some features like reliable messaging and security around that transfer, unless it's transport security, right? We can't use message security. We will attain, basically still be improving performance. Of course, there's no parsing, improving performance in terms of size of transfer. It's pure binary, and improving the actual performance of the machine, because we're not going to be bloating with memory. Because imagine loading for all the hundreds of thousands of requests you get at your server, you know, the binary data that needed to be loaded into memory to send those messages if they're downloading files, ABIs, whatever. That would be a problem. So how we configure this is we need to return or receive a stream. So this is an example, get media stream returns a stream object. You can return a memory stream, but of course it makes more sense to stream from a file so that you're not bloating memory or using server memory resources. And the binding, of course, needs to change the transfer mode to streamed. Now what happens in the implementation of the operation is you open the file, you return the file, you do not close the file. WCF will handle that for you when the final read is complete. You only close the file if there's a problem. And this is in the case of the server returning a stream. Of course, the opposite is true if the client is sending a stream. So you can stream over NetTCP binding, NetName pipe binding, or basic HTTP binding. By default, we are buffering. If you want to stream in both directions, you set it to streamed. If you want to stream only the request or the response, then you set it accordingly. The client doesn't need to set this if the server is the one returning the stream. But if the client is sending a stream, of course, it needs to deal with that. So I'll quickly demonstrate an example that I have that illustrates watching the stream being read, actually. And how I've done this is I have implemented a trace stream. So basically I've got a stream wrapper which receives the original stream and returns this stream. And basically I'm tracing to the output window every single read, every single call. Okay, so down here we've got every request that's possible on a stream in terms of reading, writing, closing, and so forth. You're going to see those traced. Okay. Now, that's just for illustration. So it's the Media Manager service that we're talking about, which I already talked about in the slides. We're going to return a stream when the client calls get media stream. The media service is going to open a file and return that stream. And then we're going to watch the output window. So let's go ahead and run it. And what the client is actually doing is it's going to try to download a MP3 file to play. And when we hit play, it's going to receive the stream from the server, but notice it hasn't read the stream yet in its entirety. We've completed the call, but all we did was read enough to find out what's the length of the stream and so forth. That's just WCF setting up shop to do the reading. Notice I'm about to close the proxy, and then I'm going to assign the stream to the media player. And it's not being read in its entirety yet until media player plays. Now because I'm using breakpoints here, this might show us an error and I might have to move a little faster because we're debugging basically. This only happens when I'm debugging. So I'm going to run that really quick again. And this time you'll see that again, the stream is not being read at the server until media player plays, which implies that even with the proxy closed, the client side has a reference directly to that stream, and when that final read is made, WCF at the server will close that stream. So let's go ahead and play, and this time I'll run it faster, and you'll see that it's doing all the read now. And eventually it'll get to the point where it closes the stream. Continuing, continuing. Okay? Yeah, so again, debugging is not a happy thing for doing this, so I noticed that this will happen from time to time. But you saw that the streaming happened later. That's really the point here. And you know, I'm not playing the music out loud, of course, because you won't be able to hear it properly. But this is all being sent to the output window again, like I said. Every single read, 65 or 64K, right? Until it's finally done. So with that, WCF closes the stream for you at the server side after the final read. The client does the opposite. If it's sending streams, the WCF, the client, will actually close the stream after the final read. In terms of how it works in terms of the opposite end, when clients are reading a stream, it's their job to close that stream. When services are reading a stream passed from the client, then it's their job to close that stream. So what's the point of streaming then again? Is that it will give you the ability to reduce memory overhead as opposed to MTOM, which still buffers the entire item in memory. And if you want to have a workaround using MTOM, but not necessarily streaming because you're looking for message level security for encryption and so forth, which I'll talk about in a later webcast as well, then you can think about using a chunking channel. Yasser Shohud had posted one some time ago on an earlier version of the WCF stack, which is still available at the .NET Effects site. And so that type of approach would allow you to kind of have the best of both, which is sending chunks of data where you control it and you still have security around it and reliable messaging around it. So with that, I will terminate our webcast of today. Just for more information, again, if you go to thatindigogirl.com, that's my book blog site. That's where I posted samples for the book. I just recently put up the VB lab samples, and the VB samples that go with that will also be posted shortly on the same link. So I'll just be updating a post to the blog to let you know when that's all there. So I've started getting that VB stuff up there finally. And then in terms of other details, of course, my book is available on Amazon. Actually, the price is pretty reasonable, so you might want to look at Amazon instead of O'Reilly site just because it's the price better. And you can get all the code samples at That Indigo Girl. So with that, I guess I'll move and see if there's any more questions and let Tracy take it back.
Excellent. Thanks, Michelle. I do want to remind everybody that for more information, they can print a PDF of today's session. And to do that, you just want to go to the File menu in your upper navigation bar. Now's a good time to submit your questions into that Q&A panel. You just want to type them in and hit that Ask button. Also, I'm going to be posting a survey here in just a minute. If you do all, please take a moment to fill that out before you log off. We do appreciate your feedback. As a reminder for upcoming and previously recorded webcasts, you can visit Microsoft.com/webcast. You can go here to access this webcast, which will be available for download in about 24 hours. Now, if you have any webcast content ideas, something out there you'd like to see, we'd love to hear from you. Please take note of this link here. And for anybody who's interested in receiving a free 14-day trial of Microsoft Office Live Meeting, you'll want to visit Microsoft.com/presentlive. And here is the survey from today's session. Please follow the links provided to complete today's webcast evaluation. And Michelle, it does look like you have some questions waiting there for you.
Mm-hmm. Okay, so a couple of questions here. Any recommendations to avoid or reduce firewall issues in duplex pub sub scenario? You know, in terms of duplex implementation, whether it's HTTP or TCP and name pipes, I guess here's what I would say about that. First of all, name pipes is same machine only, so you're not going to be crossing firewall in that case. For TCP, when you make the call out, you're establishing a socket. And so with that socket, you have a back channel. Assuming that administrators have not locked down messages coming back in on the back channel, and I'm not an IT person, so I probably can't say, you know, how they would or would not do that. You know, unless you own the environment, there's probably always the risk that people will not be able to receive the callback. Same thing goes for HTTP. They may lock down that you're not able to receive messages back on that port. And again, you have to kind of own the environment. When we talk about duplex, it's not interoperable in terms of the protocol in the messaging at this point, and it's certainly not something that you can deploy widely in environments that could be locked down. So you have to know the environment for sure. How do you disable message size and array length quotas altogether? Well, you could make them all the maximum, so you can't disable it. You have to remember there's a security risk to allowing the largest possible size to be transferred blatantly like that. So I wouldn't recommend doing that for all bindings. I think you should have contracts that are for large messages, and only those contracts are exposed on a binding that supports large messages, and that protects you better. So I guess the way to do what you're saying is, if you don't care about that or the security aspects or potential issues with overhead on the server in terms of memory usage, then go ahead and make it the largest possible size of a, I think it's a 64-bit int on each of the message size quotas. Are my demos from the book? Yes, the book has these examples, and many, many more actually in the directories related to bindings. Actually, is where all the duplex samples are, and so forth. If you have any problems finding a particular sample, feel free to email me. What does chunking channel affect, and what is the URL WCF effect for that site? Okay, so a chunking channel implies that you are still hitting the same URL and the same operation, but somewhere down below you've created, which is a very advanced thing to do, you've extended the environment to create a custom channel. And that custom channel will take the message that is being sent, basically the URL or whatever, or the data that you're trying to pass, and instead of loading it all into memory in order to build the message and serialize it, it will send a piece at a time. So it's really quite a lot of work to do that, but like I said, there is a sample out there that you can start from and probably work with. Sample codes are on thatindigogirl.com. If you review this webcast again, you can find my website information there as well. To support reliable and durable, does WCF rely on MSMQ? So the question is, if it relies on MSMQ, yes, durable would have to be MSMQ. And so you would use the net MSMQ binding, and I am going to talk about that in an upcoming webcast. And how does that compare to the SCA SDO model? You're talking about the Java specifications, I think, for SCA, and so data objects and the Indigo-like spec in Java. That I don't think relates because MSMQ is proprietary. In terms of SCA and SDO, I'm not intimately familiar with it, but I do know that it's really trying to implement reliable messaging, as far as I know, which is the same transient reliability that we get with reliable messaging as in WCF. So it's not really trying to replace the durability aspect because that's not interoperable. When you use MTOM, the server can't close the connection until the transfer is over. So when you're using MTOM and what's happening, you're usually buffering that, not streaming it. And so what will happen is the server will form the message in memory and then write it to the wire. And so you're right. I mean, the server can't close the connection because it's got to transfer the entire blob to the wire. That is correct. Whereas with streaming, of course, the connection still has to be open in terms of the stream needs to be available to the client. I mean, you certainly can't close the stream until the client has finished delivery. Okay, still getting through some questions here. Can I explain again why we had to make the service re-entrant since the callback was not one way? Because imagine the visual of a client calling a service and the client has not yet been released. And so, well, actually that's not related at all, because let's say the service has received a message from the client and at that point is about to call out to the client from the service. What happens is the service object that's been constructed only allows one thread in at a time unless you release the lock. So what happens is the service instance is in the middle of processing a request. If it calls out to the client and does not release the lock, then it cannot return with a response. So it can't be a two-way operation that requires a response. It has to be one way so that the service won't care about returning messages. Because remember, request reply implies a message comes back, and a message can't get in to the service because there's a lock. If you make it re-entrant, then it will work. Okay. MTOM stands for Message Transfer Optimization Mechanism. It's a standard on the w3c.com. You can take a look there. Can a one-way operation use UDP instead of TCP? Well, there is no UDP binding as part of WCF, but I believe there is a sample UDP binding on the WinFX3 site. So you can probably get that there. In terms of can you use one-way with that, you know, as one-way operations can be done on any binding. Okay, there's a question here. If the streaming service is hosted in ASP.NET with a 2 gig max request length, is there any way to transfer files larger than 2 gig? Well, no, because ASP.NET's limitations are going to, you know, still be enforced if you're hosting in IIS. So you're still going to have that limitation. Now, what you could do is you could host the WCF service in a Windows service and still host it over HTTP if you like, and then that could be a workaround for that. Can I explain what I mean by returning stream, return stream, sending stream, or incoming stream? Okay, so when a client calls a service and says, get me this stream of data, then that implies that the service is returning a stream. And so it needs to open the file stream, return that to WCF, and then WCF will use that stream to transfer the data to the client, basically giving you the illusion of real streaming, real file streaming, but it's really still sending messages. And then the client has a buffer to receive those, and as it's receiving, it's actually pulling from that stream so that it's not loaded into memory, right? In terms of sending a stream, then the client is sending the stream to the service. So that would mean that the service receives a stream object, which means the client opens a file and then passes that to WCF through the proxy. So, you know, send stream and then pass a parameter of a stream, which is an open file stream, and then WCF at the client will handle closing that stream when the service has completed its reads. Okay, that's it for the questions.
All right. Well, with that, I do want to extend a very special thank you to you, Michelle, for answering all the great questions we had come through the queue and the wonderful presentation for today. Well, ladies and gentlemen, this is going to conclude today's session. I want to thank you for joining us. You may now disconnect from the audio portion of today's presentation.